So just, let's use the time a little bit. So my name is Jost Bernasch. I come now from Austria, Virtual Vehicle Research Center. So I'm since 22 years in Austria, originally from Germany. So I was 12 years with BMW in Munich, from 1989, starting with the big Prometheus project. So driving assistance systems. I built up the driving simulation software at BMW. We developed the headlight, the adaptive light control in the mid of the 90s, so the first light simulation. And in 2004, I changed to Graz, where we built up a research center. And now I can tell you, I think in some seconds, what we are doing. Yeah, there it is. Yeah, I think key technology is really data-driven software development, but also software, hardware, co-design. What we see today in the automotive industry, though we have a lot of problems, a lot of delays in projects. If you go back 5 years or something, it was no chance that an OEM at BMW that the SOP is 6 months late. So it would be a catastrophic. But today it's quite usual. Nevertheless, whether it's in the US, partially in China, German OEMs, Rivian, Apple canceled all the project. So we have a lot of problems, often concerning software development, but the overall complexity in the car, though we have many delays in the development. Why is this happening? So we have hardware and software with really increasing complexity. We have not only the development, we now have the operations, so software updates, so we have to cover also the operation. We started with having one ECU for one kind of typical functions, so many functions, a lot of ECUs. So we're earning a lot of complexity, interdependencies between all these functions. So this complexity is really exploding. But we don't have to forget about the classical vehicle requirements, safety, comfort, today the battery, energy management, all the legal requirements coming up more and more worldwide, and also concerning virtual validation to speed up the development, having virtual validation for certain functions. So these requirements, and we will have a big change in the platform, in the computational hardware platform. So the electronic platform is changing a lot. So we're going to central ECUs with some zonal ECUs and so on. And what we will see is a change of how software and hardware is working together. So instead, in the past, we have a tight coupling of software and hardware for some special car, for, let's say, for Golf, Passat, and so on. You have very special solutions. And the intention is to have a loose coupling so that you have the fast software development, software updates, and you have the hardware development on a different time scale. So we have 2 time scales which has to be addressed in software hardware co-design. So in the past, at the start of production, software and hardware just was fixed, and it's running for a couple of years. This is changing a lot, especially in China and the US. So Tesla was the front runner, but now they have the most software updates per month or per year right now. And on the places 2 till 8 or 9, Chinese companies are following, and German OEMs are starting place 15, place 20 concerning software updates. But this will change. So you will have software updates all the time, changing functionality. Even the discussion is, have you all legal requirements fulfilled that the car might still run on the road if you change the functionality a lot by software updates. And how to handle these different cycles. So you have hardware cycles more concerning 3 years, 4 years, and software cycles inside months, even days. We started about 15 years ago with a multi-domain simulation, multi-domain development with almost all OEMs in Germany, all over Europe with the tier 1 suppliers. So we have a long experience in that. And I would like to address 3 development threads which has to follow and which also are playing together. So energy, safety, comfort, all the classical important properties of the car is one important threat. Then software-defined vehicle, all the functionality, autonomous driving, and so on, all the assistance you have today, and they will increase. And the change in electric design, high-performance computing in the car. So if you look at the development process, you have to come from all the requirements, and this should be done more automatically concerning virtual testing. You have to derive more automatically all your simulations and your testing, and then you go stepwise to the real testing. And we have developed a kind of co-simulation which combines hardware and software modules. So you can go step by step into the hardware. It's not one big step, but you can go step by step into the hardware. And then today you have also to look at the system operation, to the software updates, and also data coming from the car again into the development. So concerning data-driven, you have in these 3 development threads, you have a continuous data provisioning of thousands of data sources which have to be managed in every of these three threads. But finally, for certain cars, all the configuration of the data used for these 3 threads has to play together, that the car is really working and that you don't have to push your start of production 6 months, 9 months, or even more. So connecting these kind of software-intensive systems, which is a big topic today, but also all the classical vehicle domains, as well as the new high-performance computing, which is coming up into the cars. These are the challenges of tomorrow. And why is data-driven so relevant? If you just look for one car, you have certain software version, you have some additional settings which you might buy on the market as additional hardware and software, you have a certain generation of hardware, and this works fine for one special car. But if you have millions of vehicles, countless of different software versions, software updates, you have certain hardware generations, all these 3 threads are influencing each other, yeah? And you really have to manage this, and if a bug is occurring, how to address this, and will this influence other versions and other configurations. So the task is really quite big. And we started already 10 years ago, in the last 5 years very intensively with a project. How the future engineering, so we are in the strategy steering board of some OEMs discussing how will the development, virtual development, with all these aspects, what kind of properties will drive the development in the future. So future competitive and process performance is very largely dependable that you have thousands of data sources. So the OEMs we are working with, we are already connected hundreds of data sources for the development. You must address the context of the data sources so that during all the development you have a very well-defined status of your data configuration. You must know what you are working with. The engineer, the management should rely on the same data status for decisions and for the development. Then, as I already mentioned, automated simulation, automated validation should be derived, maybe with more generative AI, as we heard in the morning. Automated simulation should be derived out of these data because you don't have all these engineers to make these complex simulations. It must be more automatically, and you must be aware what kind of data you have to use and have been used. Also, you have to document this for legal issues. And systems engineering is getting a big task, model-based systems engineering, because of the 3 development threads I have shown. They have worked together and they must work and it must behave properly in the specific car with all these properties together. So it's very important to have a digital thread. So all of your thousands of data sources, they must be available, they must be accessible. This is not easy if you go into the companies. We have worked with some companies which are here also. This is still a big problem. The traceability, for example, for especially VW, is very sensitive to this problem. You know why. And they have to document all the processes, what kind of software versions, when the decisions has been made on which kind of sources, which kind of data. So traceability is extremely important. And the context of the data, so which data are influencing other data, which data fits together. So the data accessibility and synchronization is a very important task to develop a car in time. Why this is so important? So a simple example, connectivity, context, and semantics of data. What does this mean? You have really a huge amount of data in every big company, simulation data, ERP, SAP, delivery, parts, everything. So you have a lot of data available, and you can sort it in different ways. You can arrange it and present it in different ways. You have data lakes in the big companies, and they are really unlucky with the data lakes. Why? Because you are lacking the context and the semantics. If you put this together, then you have the information, then you have the knowledge. And to access the knowledge and bring the right data together, the context of the data, this is a key aspect in all tasks of development. So what we have developed in the last 5 years, together with a large German OEM and a big software company, is a system called Data Context Hub, which tries to help to avoid all the data silos. So there are thousands of data silos in big companies, to bring this together and to make decisions based on well-defined information. And the concept behind that is intake to contextualize the information and delivery, so the application. So we can read in arbitrarily kind of data, geometric data, software, vehicle characteristics, market data, costs, Excel sheets, whatsoever. We map this on a map database where we derive partially automatically based on AI, but also partially based on knowledge engineers. So the big OEMs are having knowledge engineers putting additional knowledge, annotating the data and the context of the data, so that you have more and more knowledge in the data, and then you can derive different kind of applications. It could have the engineers, the developers, but also the mid-management, but also the top management, because they can rely on the same configuration of data. And this is often the big problem, that some developments or some decisions are on different data inside the big houses compared to other groups. So this works in a big OEM since 3 years, even for very, very large tasks. And I think in the future, these controlled usage and access to data is getting even more important. You may know Catena X as a big project and activity. Catena X allows, based on the data, that on a defined way, you interchange even trusted data between OEMs and Tier 1 suppliers, for example. And all Tier 1 suppliers are pushing, all OEMs are pushing Catena X at the data interchange, trusted data interchange between the OEMs and the Tier 1 suppliers. And in order that this might work really properly, you must have a base where you really can access and control all your data and bring the appropriate data together. Yeah, some examples what we have did additionally in our research center. We have been founded 2002, so it was the start of a research center for virtual vehicle development, growing up to 300 people right now, working all over Europe in a lot of European projects in Horizon 2020, Horizon Europe. And now we have just finished financing for the next, or partially financing, of course, only for the next 10 years. So we are very active in automotive, rail, but also some other domains, primarily in Europe, but also some customers worldwide. We are working with Apex AI. They have, Jan Becker was at Bosch at that time. And we are working with him very closely together, for example. So as I said, we developed this tool where you can integrate different kind of data, and which is important if you import the data from time to time, every day, every week, depending on the original system, which remain the original system. Then you also import the access rights. So who can access which kind of data? So these access rights are also built into the map. We have a very robust graph structure in some performance measurements compared to really large software companies. We have shown it's really very, very efficient. And we are right now for a big OEM combining this with Gen AI methods that you can analyze, and like a ChatGPT for all your internal data, you can ask inside the OEM and can analyze accessing all your data if you have the access rights, also with the explanatory way. So this is just being built up and will be demonstrated at an OEM next month. So arbitrarily data inside from the OEM, also accessing additional data from the outside if necessary. This is all building up in the data context hub, and together with Gen AI applications, you can use it as a test generation, simulation generation, even for marketing, for the test engineers, development engineers, for the management. So the big advantage is that on one defined data status, all the application, all the people can access on the same quality way. Some other activities concerning automated simulation, automatic system simulation. So based on a functional architecture each OEM or each product developer has, for example, like enterprise architect or system architect modeler from ANSYS is now on the market with System L2. And accessing the data with an appropriate system, you can import all the information you need. Test cases, simulation models, configuration data, and then you can derive automatically all the complex simulations, also what Bosch has shown. You can automatically configure all the simulation, putting in a co-simulation a complex system together, and this could be done automatically. Or we have shown for an OEM to do this automatically. You have to define KPIs. It could be the assessment of the KPIs, could be also AI-based, it could be human-based, so that you see what has to improve or what has to be designed. But to automatically derive these kind of information and assessments, this will speed up the development efficiency. Simulation is always a big topic, big discussion. And how credible is a simulation? What is the quality of the simulations? This is a key question. And there was a big European project with majority of also German companies in the last 3 years. And there was derived methods how to assess the quality of models and the quality of simulation. And the result of the project is now being prepared for an industrial standard with an Intex group. It will call Model and Simulation Spice, a little bit similar like A-Spice for the software. And this will enable to assess the quality of models and simulation in the future. And this is very important for virtual validation. So this is an example where you see that in the co-simulation you can combine and configure automatically a lot of different simulation models. So the environment, the crash behavior, the different kind of sensors are simulated, the safety controller for the airbag. And you can run thousands of these kind of simulations and can change some data. Yeah? You can change if you use a more expensive sensor, for example, or if you use another software for the airbag controller or anything else. And then you can assess your KPIs and can run automatically these kind of complex software designs. some years ago, we had the first automatic driven research car in Austria. This is on the Formula One track in Austria. We are running there, but also on public roads. It has a fixed, of course, EE architecture, but we change the software quite often. We are working with Apex AI together, relying on AutoWare. And what we did is that the development in a virtual environment could be put into the car inside 30 minutes. So it's a mirrored environment, what is done in the car and what you are doing in your simulation. So this could work very closely together. And we have been part at the Robo Race in the last year. So it's an autonomous racing of robo cars. And during Corona times, it was only in the racetrack on Las Vegas. So all teams are sitting at home in their garage, making the software, improving the software. The software has been loaded up to Las Vegas, and then the autonomous car race was there. Every prototype value $1 million. And the engineers never touched the car. They only make the testing in Graz for our team, load up the software, and then the race took place. And this is the kind of development you would like to do with software and hardware, independent on the hardware availability and driving really around. Yeah, let me summarize. I think for future engineering, really key enablers are that you can handle the complexity of these three complex development threads I have shown, the collaboration inside the company, because more and more system-oriented the functionality is compared to the past, and also working together with the tier one suppliers to adapt to changes. So we have a lot of changes every year in requirements, and we need a different culture mindset that you really work with data, that you use traceable data, and with a data-driven development, including automated engineering, software-defined vehicle, and a new architecture on the electric hardware, you need to use new methods, and I think a reliable data-driven method is very important in this way. And yeah, you should be open to new methodologies, and don't say, oh, I'm so busy, I don't have time to improve. Thanks a lot.
Thank you very much, Dr. Jost Bernasch.